Welcome CTM students to lesson for 13.1. We are talking about sampling techniques. Moving on to statistics now. Lots of new vocabulary here. I'm going to define what I think are the most important things. Other ones I'm not going to formally write out with you, but we'll talk about them and we'll refer to them. We will refer to them as we go through things here, but I will define what I feel like are the most important ones for you to know. We'll actually write those ones out. And as always, make sure you're using those extra examples in the book to help you out as we go through this. So let's define, first of all, what statistics is. That's going to be very important for us to know what is statistics and how is it different from probability. The two are pretty closely related. You'll often see them intertwined, meshed together, taught together. And so we did our probability chapter, now we're doing some stuff with statistics. Statistics is kind of an art and kind of a science at the same time. So I'm going to say the art / science of gathering, analyzing, and making inferences. That's right, I said inferences. You might not have heard that word before. Inferences just means it's another way to say predictions. So you are inferring something based on the data. Inferences or predictions from a set of data. So maybe you take a survey, and from that survey you make certain inferences, you make certain predictions based on the data that you gathered and analyzed. That's statistics in a nutshell. And so population and sample, those are a couple other things that I definitely want to define here. Other terms that may have showed up in the vocabulary list there, we'll talk about as we go through this lesson. We'll talk about as we go through this chapter as well. But a population, that consists of all items. It's all items. Or sometimes people is often what the items are, so I'll say / people in a group. So your population might be the population of the United States of America. It might be the population of our class. It might be a population of our school, something like that. Sometimes it's not always easy, not always even possible to take a sample or to take a survey of everybody, or to take a certain measurement of every single person in the population. That's why we have things called samples. So a sample is supposed to be representative of the population. A sample is a subset. If it's a good sample, it's supposed to be representative of the population. So it's a subset of the population, though. Subset of the population. Often used to make predictions about the entire population. So you may have heard of something called the Nielsen ratings before. That is a group that takes statistics about TV shows, and so they watch a certain sample of the population. There's no way to keep track of what, at least the way our TVs are set up now, there's no way to keep track of what every single person is watching at every single hour of the day. It would just be too costly, too much data coming in. So they take this sample size, relatively small compared to the entire population of the United States. They're taking that sample size and they're basing their predictions, or what they're making their inferences about the whole population of all TV watchers in the U.S. based on the few thousand that they might be looking at. So a few things there about the definitions of a few of the words we saw. Now I want to make a little table here. So we're going to make a table. You're going to want about a half page for this table. Excuse me. And I would say leave 3 lines for each one of these. So if you have the normal blue line paper, leave 3 lines for each one of these. We're going to have our headings up here and then 5 different types of categories. Okay, so get that, drawing something like that on your paper. Up here I want you to put the sampling type. So there's different types of samples we can take, and over here is the description. So again, it's not very often, it's not very easy. I can't think of the word I want to think of right now. You ever have that? That's happening right now. It's not very easy. It's very hard, very difficult to take sometimes the whole population and to take measurements or certain characteristics, find out certain things about that entire population. That's why we have to do certain sampling types. We have to take different samples to try to represent the whole population. So we're going to have random, we're going to have systematic, should spell that right though, systematic there, like system, and then A-T-I-C. Cluster, sometimes referred to as an area sample. Stratified, and convenience. Those are going to be the 5 types we're going to talk about in this lesson here. And you're going to notice with this lesson and the first couple lessons actually in this chapter, there's not a whole lot of number crunching going to be going on. We're going to be talking more about definitions, more about why is this a good sample or a bad sample, or why is this a good graph or a bad graph. We're going to be making judgments of things, more word problems, I guess you could say. But don't let that scare you. So these shouldn't be hard. We just have to make sense of what's there. So random, I'm talking about other things. Let's talk about this now. Random. So each item of the population in a random sample has the same chance. Has the same chance of being selected. If you want to read more in depth in your book about things, it's all in there. I'm trying to just take snippets, take the basics here, and really boil it down to its essentials and put that in this table format. So being selected often, so I've got a little semicolon to separate my thoughts here. Often we'll use, or you would use, randomly assigned numbers to make selections here. So randomly assigned numbers to select. I'll say it like that. Systematic. This one's easy description here. It's every nth item. So maybe it's every 5th item, or every 7th item, or every 26th item. It's every nth item. N could be any particular number. Every nth item is selected. A cluster sample or an area sample is something like this. It's often selected based on a geographical area. Semicolon action there, and randomly selected areas / clusters, you might refer to them as either one, in the entire area. So maybe your entire area is a city, and then you break it up into different neighborhoods, and so you would randomly select some neighborhoods, some areas or clusters in the entire city. So in the entire area in general, your area are analyzed. Stratified. What's a stratified sample? This is where the population is divided into different parts. And here's where the stratified word comes in. You could actually call, I should finish my thought there, different parts. Here we go, different parts. Sometimes we refer to those parts as strata. So that's a fancy way to say different parts. So strata, different parts, different strata. Like, these are just some examples. There's more than this, but like gender, like race, religion, income, and so on. So I'll say etc. And then analyzed within each strata, or within each part is another way to say that. And finally, a convenience sample. This one I would say is the least reliable sample, but it's readily obtained data from convenient sources. But just because it's convenient doesn't mean that it's a good sample. So I'm going to write down a little extra with this one here. It's often not representative. And these other ones could be not representative, but there's a much less likely chance that that's the case, but often not representative of the entire population. And so we'll do an example, and that'll actually be it. We're just going to do one example for this one. No number crunching, just identification here. So identify the sampling technique. So we're going to go back to that table we just did. Identify the sampling technique used to obtain a sample in the following. And you're also going to explain your answer for each one. So there's going to be some different parts to this one. And I'm going to give you an example of each one of these types, but I'm not going to necessarily put them in the correct order. So see if you can guess these, or take an educated guess, make a hypothesis about what you think each answer is before we write it down here. So what if this was the situation you were given? Every 18th jar of peanut butter, peanut butter, it's good stuff. Peanut butter, get the natural stuff, don't get all that excess sugar. Blech. So every 18th jar of peanut butter at a manufacturing plant. What type of sampling would that be? So I think this is probably the easiest one, because they're saying every 18th, you can replace 18th with nth, so every nth item is selected. If that's going on, maybe they're just keep coming down the assembly line, or keep coming down the peanut butter treadmill, I guess you could say. Boy, I just can't think of words that I want to say today. So the peanut butter just keeps coming down the assembly line. You pick out every 18th jar of peanut butter. What kind of thing is that? What kind of sample is that? That's a systematic one. So this is systematic. And let's write Y after that. So systematic, because every nth, and in this case n is 18, so every 18th item is selected. Okay, let's do another part, or another type that you might see. A door prize, let's say a door prize. So you attend a place, you get a ticket, you get your name put in a hat, something like that. A door prize is given by randomly selecting a name from a hat. So let's say that is the case, and this is going to be what? We're going to mix these up in the hat. We're going to just blindly pick one. This would be if we go back to here, That sounds like not a cluster. You're not segregating the group into different areas. Stratify, we didn't separate people into your male, female like that first, nothing like that. Convenience, no, because you're taking everybody that's there. This is more of a random sampling type. So this is random. Why is it random? Because I think the easiest way to say this, something like this: each name has an equal chance of being selected. Okay, I'll put a period up there too. There we go. Part C. Part C. How about this? A lake is divided into different areas. And just based off of that sentence, you might be leaning one way with your answer for this question. But let's say 3 of those areas are selected to be tested. Selected, there we go, to be tested for water quality. So what kind of sampling is that? So if we go back to here, what we're talking about, this is more of a cluster type. So you're selecting, this is a geographical area. It doesn't have to be geographical, it just could be a certain area of the whole thing that you have. Maybe you have this massive pile of boxes, or massive pile of I can't think of other things. Massive pile of books right now, and you just pick a couple different areas from that pile of books and you just select from there. But here we got this lake. You're selecting certain areas of the lake to analyze. This would be one of those, a cluster type, because why is that? It's a random sample of specific areas. Okay, I want to continue this example. I'll go to the next page. And how about this? A couple more. I want to show you an example of each one. So the first 20 people entering a national park are asked if they feel strongly in favor of protecting the environment. Now, without saying anything about whether that's a good sample or not, what kind of sample is it in the first place? What kind is that? That sounds like a convenience sample to me for sure. So this is readily obtained data. These people are right there. We can just ask them the question on their way into the park. Now we don't have to go and sort people, divide people into different groups, or say you're given this number and this number and this number, and then put names in a bin, or randomly select using a random computer number generator and do something like that. They're just getting asked on their way to the park, and that is a convenience sample. So convenience, because data is collected easily, but then I'm going to say but not randomly. And so think about this. Is this a good sample? Now let's ask that question just to talk about it a bit. Is this a good way to pick a group of people to see if that's representative of maybe the whole population of the United States? People that are going to a national park, I would say in general, are going to want to protect the environment because they're going to a place where it is protected and they appreciate that. And so I don't think that's necessarily the best way to choose, or to take a survey of 20 people if you're trying to get a true representation of how the entire population of the United States feels. Am I in favor of protecting the environment? Yes, I love national parks. There's usually a strong correlation between something like this and this, just as there might be a strong correlation between another convenience type sample. Maybe you got people walking into a movie theater and you ask them, do you like movies? Well, most of them are probably going to say yeah, because they're going to the theater. But people that don't necessarily go to movies, they might not like movies as much. Hopefully I can continue to talk without stumbling over my words for this last. I can't do it. Without stumbling over my words for this last part, Part E. A company's employees are first classified by their respective salaries. So maybe you've got a group, this is the group that makes $30,000 and under. Maybe it's the part-time employees or the I don't know, whatever staff at the place you've got that makes under 30,000. Then maybe you have a 30,000 to 50,000 bracket. Then you have a 50,000 to 100,000 bracket, and then 100,000 on up. Maybe you're splitting them up like that first. So respective salaries. From there, a random sample of 10 people from each salary bracket is selected. So let's say that's the case. What kind is that? Yes, we've only got one left. Yes, it is a stratified one, and I said I'd give you an example of each one. So this is true, but why is it true? Well, we're dividing our population being the company's employees, into different parts. We're segregating them into parts or into groups based on their income in this case, based on their salary, and then you're analyzing each part from there. You're taking a random sampling of each part from there. So let's write that down in a what's the word I want to use now? In a efficient manner, in a succinct, that's a good word right there, in a succinct manner. So it's stratified because people are first classified by a characteristic which in this case here it's salary. So salary here, I'll say, before random samples are taken from each part, or each, if you want to get fancy with it, why not, each strata. So from each part, each strata. So there's other ways you can word this, but just an equivalent way. This can be in your own words when you're doing problems like this, if you're trying to decide what type it is and why it is that type. But it should be equivalent in meaning to what I'm saying here. So you can use this as a tool, a guide to guide you in the problems I may be having you do. Check out example 1. They only have one example for this lesson in the book as well, so check that out. I tried to correlate those very closely to what you have here. Some different examples, but similar ones for sure. Let me know in class if you have any questions. And again, for the next couple lessons here, not going to be too much number crunching. Going to be more deciding what's what based on reading through some sentences. Hope you are doing well, and hope you have a good morning, evening, afternoon, whenever you're watching this. Hope your day goes well. Bye-bye.